By this point, you probably can determine if a molecule has symmetry or symmetry elements associated with it. We're now going to explore another aspect of the form of molecules, and that is whether or not they have handedness. So our learning goals in this video will be to develop the ability to visualize mirror images of molecular structures. As we'll see, this is intimately tied to this whole principle of handedness. So let's talk about handedness. What does it mean to be handed? Okay, this is a picture of a pair of hands. The simplest definition is that hands are mirror images that cannot be superimposed. In other words, you can't take the left hand and overlay it with the right hand because the thumbs are on the opposite sides of the hand, and the palms also would be pointed wrong if they did line up the thumbs. So two hands are a perfect example of mirror images that cannot be superimposed. Let's make another analogy. We're going to consider two twins, Mac and Jack. Mac becomes a banker and Jack becomes a pirate. So what happens later? Well, sometime later, Mac may look like this, and Jack might look like this. He's a pirate after all. There are mirror images now. We can see that Mac actually looks just like his mirror image, whereas Jack, there's a problem. The eye patch and the scar prevent him from being superimposed on his mirror image. So Jack's face has the quality of handedness to it. You can always tell whether you're looking at Jack or looking at a mirror image of him. So in order to see this in molecules, we're going to need to have some facility with visualizing spatial relationships. So when we perceive handedness, we need to be able to visualize 3D objects from multiple perspectives. So let's consider, for example, constructing a Newman projection looking down a CH bond from behind. So here is a molecule. It's got a carbon. It's basically a methane derivative that has a carbon, a chlorine. It has a chlorine, a fluorine, and a hydroxyl group attached to the carbon. Now, what does this molecule look like if we're looking from the other side, if we're looking from behind the page? Can we imagine that in our mind? Can we imagine going around behind this molecule and seeing what it might look like? Well, here's a representation of what it might look like. You can see that the fluorine, which is starting off in the rear on the left, is now going to be in the front on the right. And the chlorine, which is on the right, is going to end up on the left. The hydroxyl group stays pointed straight up, and the hydrogen, which is sticking out in the front in the original molecule, is now sticking around behind us. So as we look down the carbon-hydrogen bond, we might note that there is a certain directionality if we go from chlorine to fluorine to hydroxyl, and it goes in a counterclockwise direction. Now you may wonder, why am I worrying about this? Well, this is going to be the key to understanding when something is handed or not. We're going to pay attention to this clockwise rotation that would go from one object to another attached to a carbon atom. So now let's consider the molecule again. All right, here it is, the original molecule. And now I look at it in a mirror. Now I'm going to take the mirror image and slowly move it around so that we're basically rotating it on the screen. I know it could be something faster, but this is the best way I knew to show you that we're preserving the structure of that mirror image while we rotate it on the screen. Now we have the molecule and its mirror image both showing there. Are they the same molecule? Well, remember that the original molecule had chlorine, fluorine, and hydroxyl group in a counterclockwise rotation. We can now look at the new molecule and look down that carbon-hydrogen bond, and what we see is that chlorine, fluorine, and hydroxyl group are now in a clockwise rotation. So in other words, it has reversed the sense of rotation that goes from one group to the other. This means that these two versions of the molecule are not superimposable on one another, and because they're not superimposable but they're mirror images, this means that this molecule has the quality of handedness. What we're going to be doing is exploring this quality of handedness in various different manifestations over the next few lessons and see if we can understand what it means for molecules to have this quality of handedness.